All right, imagine this for a second. You wake up tomorrow, and you're on a world where the sun just doesn't exist. No sunrise, no seasons, just an infinite, pitch-black void. Crazy, right? Well, welcome to this explainer. Today we're going to explore the terrifying, but honestly absolutely captivating reality of starless worlds. And, as you'll see, we might just discover why they could be the most common home for life in the entire universe. Let's get into it.
So what actually happens if our sun just vanished tomorrow? I mean, we wouldn't just be stumbling around in the dark. Our whole concept of what makes a world habitable would be pushed to its absolute breaking point. We always think of the sun as this indispensable engine of life. And, for our surface here on Earth, that's 100% true. But what exactly goes down when the cosmic lights get switched off?
Well, it gets incredibly deadly, incredibly fast. Without the sun's heat, the globe's average temperature would totally plummet. We're talking negative 73 degrees Celsius in just a single year. That is unbelievably cold. Photosynthesis, it stops instantly, which means the entire surface food chain completely collapses. The oceans would literally freeze solid at the surface, and all that weather we're used to, winds, rain, clouds, all of it driven by solar energy, would just stop, dead in its tracks.
And that forces humanity into a desperate, ultimate choice. Our familiar sunlit life on the surface? Completely gone. The only way we, or really any life, could survive is by retreating deep, deep underground. We'd have to rely entirely on the heat coming from inside the Earth itself, geothermal energy. Actually, right now at the very bottom of our oceans, hydrothermal vents power whole ecosystems without a single drop of sunlight. We'd basically have to copy that exact model, using nuclear, fossil, and geothermal power just to keep isolated underground bunkers alive.
Okay, moving into Section 1, trillions of cosmic nomads, the unseen majority of the Milky Way. See, this whole thing isn't just some wild, hypothetical scenario for Earth. It's an actual, staggering reality. Our galaxy is already absolutely teeming with worlds that exist in this exact kind of perpetual darkness. We call these objects rogue planets. They're basically these cosmic wanderers that have been violently kicked out into the dark void. Picture this. During the super chaotic early days of a solar system forming, you get these intense gravitational tug-of-wars between giant planets, and they can literally slingshot smaller worlds completely out of their star systems. From that moment on, they just drift through freezing interstellar space, totally unattached to any star, like cosmic orphans.
Now, take a look at this number here, 21. For the longest time, astronomers thought rogue planets were just these rare, freak anomalies. But a massive 2023 study published in the Astronomical Journal used 9 years of gravitational microlensing data to figure this out. They calculated there are about 21 rogue planets for every single main sequence star in the Milky Way. Just let that sink in.
If you do the math on that, it means there could be up to 6 trillion, yes, trillion with a T, dark worlds wandering our galaxy right now. 6 trillion. That means they completely outnumber the bright sunlit planets we usually spend all our time studying. And get this, most of them aren't giant gas planets either. The data actually points to the vast majority being rocky worlds, roughly the size of Earth or Mars, just drifting out there, completely unseen.
So that brings us to Section 2, the engines of warmth, or how to stay liquid in the absolute cold. Because if space is hovering just a tiny bit above absolute zero, how on Earth, or, off Earth, does a rogue planet keep from freezing totally solid? How could they possibly harbor liquid oceans?
Well, it turns out there are 3 pretty incredible engines of warmth that don't need a star at all. First up, radiogenic decay. This is basically heat generated by radioactive elements, like uranium, cooking away inside the planet's rocky core. Second is ice shell insulation. Imagine the surface water freezing into an ice shell miles thick. It basically acts like a giant thermal blanket, trapping all that core heat down below. And third, tidal heating. If a rogue planet manages to hang on to a massive moon when it gets ejected, the gravitational friction between them actually kneads the planet's interior like dough, generating a massive amount of heat. But hey, what if the planet doesn't even have an ice shell? Back in 1999, planetary scientist David Stevenson had this mind-blowing realization. He figured out that if a rogue planet gets ejected early enough, it might drag its original thick hydrogen atmosphere along with it. And under immense pressure, that hydrogen becomes opaque to infrared heat. It essentially acts like a cosmic pressure cooker. It traps that tiny trickle of geothermal heat from the core so perfectly that a planet just floating in deep space could keep liquid water on its actual surface for billions of years. And that brings us to this beautifully named concept researchers proposed in 2011, the Steppenwolf planet. It's named after a lone wolf wandering the freezing galactic steppe. A Steppenwolf planet survives entirely on its own internal fire. Up top, it's got a frozen, totally desolate surface. But deep beneath that ice, it hides a warm, global, liquid water ocean. Which naturally leads us to Section 3, Life in the Dark, Biology Without Sunlight. Because, wherever there's liquid water and a heat source, there's a real potential for biology. Let's dive into how life could actually function when it has never, not even once, been touched by a single photon of sunlight. The absolute secret sauce here is chemosynthesis. While we up here rely on the sun, life on a rogue planet would rely entirely on chemical energy bubbling up from the hot interior, straight through hydrothermal vents on the ocean floor. The organisms down there would literally use these chemicals and minerals to build organic matter. No light required.
This is a direct contrast to photosynthesis. Instead of green leaves reaching up for the sun, imagine bizarre alien ecosystems that look a lot like our deep-sea tube worms, thriving in pitch darkness, feeding on toxic chemicals like hydrogen sulfide. It's a completely different biological paradigm. It's life, but totally disconnected from the stars.
And the crazy part? We don't even have to leave our own solar system to see a working model of this. Take Jupiter's moon Europa or Saturn's moon Enceladus. They are absolute perfect analogs for the dark, icy oceans of a rogue planet. I mean, they receive almost zero useful solar energy, yet they both have deep, subsurface oceans kept warm by tidal friction, literally shooting chemical plumes out into space. As the quote goes, if life exists there, it's powered entirely by chemistry. If it works there, it can absolutely work on a rogue planet.
Now, when you crunch the numbers on this, the math is just staggering. In 2019, scientists calculated that rogue planets capable of sustaining subsurface oceans could actually outnumber the rocky planets sitting in traditional sunlit habitable zones by a factor of 100 to 1,000. Let that sink in. The vast, vast majority of habitable real estate in our galaxy might not be orbiting stars at all.
All right, final stretch. Section 4, the inverted universe, flipping the script on the search for life. Let's look at how this entirely upends literally everything we thought we knew about our place in the cosmos and how we go about searching for extraterrestrials. In astrobiology, we are constantly asking the big question, the Fermi paradox, right? If the universe is so insanely vast and old, and life is probable, where is everybody? Why haven't we picked up any radio signals? Why hasn't anyone built some giant visible megastructure?
Well, this gives us a terrifyingly simple answer. Earth is the weird one. Earth is the cosmic outlier. As researchers have noted, the default mode of being a planet in this galaxy is not having a sun or seasons or a sky. The default mode is the dark. The vast majority of worlds in our galaxy are actually just wandering in complete darkness, completely invisible to our current telescopes.
Just think about what that means for intelligent life. If a civilization evolves in a warm ocean, trapped beneath 10 kilometers of solid ice, their entire universe ends at a frozen ceiling. They would have absolutely no concept of stars, no concept of empty space. They'd never invent astronomy, and they sure as heck would have no reason to ever develop radio technology to broadcast a signal for us to hear. So, I'm going to leave you with this final, provocative thought. What if the famous Drake equation, our go-to formula for finding alien life, is completely missing the biggest variable of all? What if the galaxy is essentially a dark, incredibly crowded forest just filled with billions of subsurface oceans? And we, sitting here on Earth, are just the rare, noisy campers sitting around a bright fire, totally oblivious to the vast, silent life surrounding us in the dark. Definitely something to think about next time you look up at the empty spaces between the stars. Thanks for joining me on this explainer, and keep questioning the universe.